Alright everybody, we're back with another algorithm video. The problem for this video is, given a integer number, figure out whether it is a palindrome or not. So here's a few examples. So this number 10101 is a palindrome, 101011 is not, negative 10101 is not, all negatives will not be palindromes, and then just a single number is always going to be a palindrome. Alright, let's look at the algorithm. So this is just basic pseudocode. First we're going to split the number in half, and then we're going to reverse the second half and check if they're the same. So we have pretty much two cases. We have a case where there's an even number of digits in the number, and then there's a case where there's an odd number of digits. So right here you can see if we have an even number of digits, we can just split it down the middle and then reverse the second half and check if they're the same. But if we have an odd, then the first half is going to have one extra digit, so we're just going to have to divide by 10 and check. Alright, so that's the algorithm. Let's go ahead and implement this. So here's the code. I'm just including a few namespace functions from OutStream, and then my driver is simply asking for a number, and I'm calling the function. That's it. Alright, and then here's our actual function. First off, we're checking if it's a negative number, because all negative numbers will be not a palindrome. Alright, and then we're setting our first half and our second half. Our first half is being set to the number initially, and then we're setting the number of digits equal to log base 10 of the number plus 1. It just kind of works out. It's kind of interesting actually. If you do any number, like if you do log base 10 of any number, it'll give you back a number that's one less than the number of digits. And really we should floor this, so let's just go ahead and do that. Because I just typed into the calculator log of 34,652, so that should be 5, and it gave me 4.53, so we don't want that rounding up because that would give us an error, so we're just going to floor it. Alright, and then we're in a while loop, and this is us splitting the number in half. So our condition is while the first half is greater than the second half, because our second half is going to be increasing while our first half is going to be decreasing. And then we're setting the second half equal to the second half times 10 plus the first half modulus 10. So what this is going to do is take the ones place of the first half number, which is, it's starting out as the actual number, so it'll take the rightmost number from that and it'll add it on to whatever the second half number, which is started at 0 times 10 is. So for example, on our first iteration it would be 10 times 0, which is 0 plus whatever is on the right of the actual number. Alright, and then we're setting the first half equal to the floor of the first half divided by 10. So this is just going to knock off one digit place from the number. And then I have these debugs. We'll look at this in a second. So after we're done splitting it, we need to check if our digits, basically if we have a odd number of digits or an even. If it's odd, then we're just dividing by 10 like I showed you in the pseudocode. And then we're checking if the two halves are equal to each other, and if they are, we're returning true. If they're not, we're returning false. So let's go ahead and run this so you can see it working. Alright, here we go. It prompts us for a number. We'll pass in a palindrome, and it returns 121 is a palindrome. We'll go a few more times, so 1 2 3 4. It's not a palindrome. And the nice thing about this version of the algorithm is it works with zeros. I had tried a different algorithm for this problem previous to making this video, and it didn't work when I put in this number, just because it couldn't recognize this 0. It would automatically get rid of that 0. But with this algorithm, it recognizes that 0, which is good. And it says it's a palindrome, which it is. Okay. So we're going to stop that, and now we're going to add on these debug cout so you can see what's happening. So we're just printing what the second is and what the first is in terms of the halves. So we're going to pass in the 121 again, And you can see the second is set to 1, which is the rightmost of the first half. And the first is then set to, well, it just gets rid of this rightmost digit, so 12. And then we do that again. The second is equal to 12, and then the first is equal to 1. And we add in odd number cases. So we drop this decimal place, or this place, from the second half. And I think I said we were dropping it from the first half. We're dropping it from the second half. It's my mistake. Alright, so let's do a bigger number this time. We'll do that one case, so 10101. So second is then set to 1, which is the rightmost. And then we drop a digit from the number, and that's our first. And then we keep doing that, so the second becomes 10, because if you read this backwards, 10. And then we drop another digit, so 101 is our new first. And then we add the 1 onto second, so 101. And then our first is 10. And then since we have an odd number of digits, we just drop this 1. And 10 is equal to 10, so it is a palindrome. Alright, that's going to be this video. Thanks for watching. Try it on your own. Catch you later.